Okay. Well, hope everybody's having a good day. It seemed like yesterday everything was going well. Okay. Anybody solve the riddle? Okay. Why was the broom late? It overswept. Okay, exactly my kind of puzzle. So there you go. So good. That is actually really good practice, getting you ready for tomorrow, which is what? Okay, not exam. The exam is on Monday the 4th. Tomorrow we just have a quiz over the vectors and the plane notes, basically the assignment, the algebra. I didn't put any word problems on there, but you want to know definitely how to find the magnitude, which we're going to practice quite a bit today, how to add and subtract vectors, even the unit vector. Do you guys remember how to find that? What was the formula? Okay, I take the component form of a vector and divide it by what? What do we call those double bars? The magnitude. Okay, so we'll definitely need to know that for tomorrow. The happy minutes today and tomorrow, I'm recording those as homework grades. We're going to have two additional ones on Monday and Tuesday, and I'm going to record those as quiz grades. In fact, on Mondays, you remember, I think it was the Monday before last, where we wrote out the answers using the inverse trig functions? Okay, like we had 2 pi plus or minus, sine inverse, cosine inverse. That is the type of problem on Monday, not tomorrow's, but Mondays. Okay, so probably not a bad idea, look back over that material, refresh yourself on it, because we only spent the one day. I mentioned the test on Monday the 4th, a week from this coming Monday. I've already started putting it together. At least half of it right now is word problems. So get ready. We still got over a week, plenty of time, but not too early to go ahead and start taking just maybe a few minutes a day looking over your material. Okay. Any questions about what's coming up? Okay. And who else needed the key? I know Bethany did, Miriam, and Xavier. Okay, so we'll just get that key out there. Okay, so let's pick up where we left off yesterday. In fact, I think your class was the one class that finished this problem, correct? Yes, okay, I thought we did. All right. We actually had that taken care of. All right, so let's move on to our next problem here. A runner's resultant velocity is 8 miles per hour due west, running with a wind of 3 miles per hour, north 28 degrees west. So what kind of bearing was I provided? That's quadrant bearing. Okay, very good. What is the runner's speed to the nearest mile per hour without the effect of the wind? Okay, so why is this problem different than all the others we've looked at so far? Without the effect of the wind. So what am I already provided? The resultant. Normally we're given two vectors which we combine in order to get the resultant. Well, here I'm given one vector and the resultant. So we kind of have to work backwards to figure out what the other original vector is going to be. So this vector where he's running the 8 miles per hour due west, let's go ahead and say that's R. That is my resultant. Okay. The wind vector, we'll go ahead and call that W. But now, what would you like to call the vector that we're trying to find? A, okay. So let's call the vector we want A. So we know that the resultant is going to be the sum of the two vectors. So the runner just running without the wind itself, and then we have the resultant. Okay. Well, which of these do we immediately have and we don't have to do any calculations? Is it the resultant or is it the wind? It's the resultant, right? Because see, with the wind, we do have the magnitude, but I would need to go ahead in order to get the component form, multiply the magnitude by cosine theta, and then magnitude by sine of theta. But we don't have to do that for the resultant. He's running due what? Due west, so what would his component form be for that? Negative 8, 0. And it would have to be negative because you're running west, left of the origin. Okay, so this would be negative 8, 0. Okay. But for the wind, as I said, we have to take its magnitude and multiply by cosine of, okay, am I going to go ahead and plug in 28 here? Okay, what would I plug in? Okay, which would be 118. There we go. Again, the one thing I want to emphasize is this quadrant bearing, north 28 degrees west, so if this is north, this is west. It's going to rotate left off the positive y-axis. So this is 28 degrees, but remember this component form formula always has theta rotating from the positive x-axis. Okay, so that's why we have to take the 90 plus the 28. That's where we got the 118. And then the vertical component would be 3 sine 118. There we go. Okay. Now let's go ahead and approximate those. Go over here to the calculator. Let's take that out. We don't need it. Let's see. It was 3 cosine 118. Oop. So what am I going to get when I push enter? Okay. And it makes sense it's negative because cosine's negative in the second quadrant. So negative 1.41. Okay, come back over here. Negative 1.41, comma. Okay. Now I want to go ahead and put in 3 sine of 118. So 3 sine 118. What am I going to get for this one? Okay, 2.65. That's absolutely right. Okay, so 2.65. Okay, so now we're just going to go ahead and do basically what we've done before, but we're going to create an equation to help me find the component form of that original vector. So remember, we know that r is equal to a plus w. A is the vector we're trying to find. So r, negative 8, 0, equals, okay, a, we don't know what that is, and we can go ahead and just represent it by a comma b or x, y. Really, the variables make no difference. Plus, we just found the wind vector to be negative 1.41, comma 2.65. Okay. And how am I going to use this to find a and b? I mean, how can I do that? I mentioned something about an equation. You remember seeing something like this on our homework? That's exactly right. One says negative 8 equals a plus the negative 1.41. I go ahead and put all the x values together according to what we have here. So negative 8 equals a, I'll say minus 1.41. And then for the other one, in fact, b will have immediately. 0 is equal to b plus 2.65. So immediately b is what? Negative 2.65. Okay. Now, what I want to go ahead and do is add the 1.41 over, so I'm going to go ahead and do this. I got the negative 8, so I've already got the negative version in here, so I'm just going to go ahead and subtract that, because what happens when you subtract a negative? It's going to go positive, so that's going to do what I need it to do. So let's say negative 6.59. Okay. So A equals negative 6.59. So what we were calling vector A, okay, even though we use the same variables, we got the horizontal to be negative 6.59. We got the vertical negative 2.65. Okay. So that's the component form of the vector we were trying to find. So how am I going to find how fast the runner was running without the wind? What have we been doing in all these problems? Starts with an M. Magnitude. And then what's the formula for it?
A squared, or square root of a squared.
Square root of a squared plus b squared. Okay. So the magnitude of A would be the square root, negative 6.59 squared, plus negative 2.65 squared. And I think it wanted to round to the nearest mile per hour. So somebody help me out with this. How fast is the jogger jogging? Oh. Okay. Alyssa. And I thought I heard somebody say it. How fast is it? About 7. There you go. 7 miles per hour. Perfect. There we go. Now, all these problems, we've been looking at them algebraically, doing the same process over and over again. Is there anybody out there who's been using the graphing method? The triangle method? Anybody sticking with that? No? Some? Okay. All right. Well, good. This one did not want me to go ahead and find the direction angle, so you don't have to worry about that. And there's not a whole lot left here for us to take a look at. Okay. So the rest of this, again, is just more supplement, kind of bringing up ideas that we discussed in the previous lesson. Okay. Two or more vectors with a sum that is a vector R are called components of R. While components can have any direction, it's often useful to express or resolve a vector into two perpendicular components. The rectangular components of a vector are horizontal and vertical. And we've actually already been using those up until now. Remember, our component forms create a right triangle. Those represent the legs. Okay, bless you. In the diagram, the force exerted to pull the wagon can be thought of as the sum of a horizontal component, force X, that moves the wagon forward, and a vertical component, force Y, that pulls the wagon upward. So if this individual is pulling the wagon to the right, well, then the horizontal is moving it to the right, but we're also moving it up vertically at the same time to get that diagonal force. Okay. All right, well, let's just get right to an example. Let's see what you guys think. The player kicks a soccer ball so that it leaves the ground with a velocity of 44 feet per second at an angle of 33 degrees with the ground. Okay, so draw a diagram that shows the resolution of the force into its rectangular components. So this one, I went ahead and started us with a diagram so that we kind of have an idea. Is there anybody out there who did not get the key? Okay. All right. So let's say, so the soccer ball is kicked like this. Okay. So we want to go ahead and draw this in terms of its horizontal and vertical components. We know that it was 44 feet per second, 33 degrees from the ground. Now, when we go ahead and draw these vectors, with the vector diagonal going this direction, up and to the right, would the terminal end be on the left or the right side? Yeah. And then where would the terminal side be for the vertical? Above or below? Above. Because in order to make this diagonal path, it has to be moving both horizontally and vertically. Okay. And all we want to do is find the magnitude of those. So basically we're talking about how fast is it moving in feet per second horizontally and how fast is it moving in feet per second vertically to give me this diagonal path that the ball is on. Okay. And then of course, I mean, it's not going to be diagonal for very long because it's going to follow a parabolic arch and then it's going to change, but we're not interested in that. Okay. So does anybody have an idea? Like, let's say X. How I can easily and quickly find X. Somebody in second period had a really good idea that I hadn't even thought of. I'm sorry, man? Yeah, I mean, we're dealing with the right triangle, so you could just go back to good old right triangle trigonometry, basically SOHCAHTOA. So Aiden says cosine. So cosine of 33 degrees would actually equal what? X over the 44. Now, since we're trying to go ahead and find the magnitude, I'm just going to go ahead and put X in the double bars to illustrate that, over 44. Okay. And then how would I solve this equation? Yeah. Multiply through by that 44. That's exactly right. So those are going to cancel, so I know the magnitude has to be that product. So let's see here. 44 times the cosine, get out of there, of 33. Okay. So it looks like I'm getting about 36.9 feet per second. Okay, probably even make an argument for 37. Okay, so 36.9. Hey. Okay, so 36.9 feet per second. Okay. And now actually this opens up another strategy that we could use. We are dealing with the right triangle, so we could simply use what? Okay. Well, actually we could. We could go ahead and use another trig function if we wanted to, because in the beginning we know this is 33, so this angle up top here would have to be 57 degrees, right? So you could use another trig function. Pythagorean theorem would also work. The idea that somebody had in second period was at the very beginning, instead of using this equation, You could use law of sines, even though it's a right triangle. You still have the angle and the side length across from it, so that would work out just the same way. So regardless of how you go ahead and do it, has anybody already figured out how fast it's moving vertically? How many feet per second vertically? About 24, yeah. What I got was 23.9. Okay. So let's say the magnitude for y is about 24 feet per second. Okay. All right, so like I said, Pythagorean theorem would have gotten you that. If you set up an equation similar to what we had here, you could say sine of 33 is equal to the magnitude of y over the 44. Okay. Law of sines, any of those. Okay. Questions? Hey. They use the law of sines, so they use this pair right here. Okay. In fact, it was, anybody know Kiva Weeks? She came up with the idea to go ahead and use that one, and I hadn't thought of it. So you could say sine of 90 over the 44 is equal to, okay, now let's say we're looking for x, the sine of 57 over that magnitude of x, and that will give you the same thing. It will give you the 36.9. Okay. All right, questions? Anybody having trouble? Okay. Well, good. Now, this next problem, let's see, what was it? Heather's pushing the handle of a lawnmower. This time we have force in newtons. So it's the exact same type of problem. Would you guys like to go ahead and take a look at it, or do you feel confident? You feel comfortable enough we can move past it? Does anybody want to work this problem? So if this problem were provided, say, on a quiz or a test, we would absolutely get it, no problem, no questions. Jack? We do want to work it? Okay, let's work it. All right. So Heather's pushing the handle of a lawnmower with a force of 450 newtons at an angle of 56 degrees with the ground. Okay. So let's say we got the lawnmower right here, and this is going to be a very rudimentary lawnmower here. Okay. So there's the handle of the lawnmower. Okay. So the vector would actually be pushing it here. So what two directions are you actually pushing this handle, this mower? Okay, down and to the right. Yeah. So the component form, there we go. It's going to be looking at something like that. Okay. All right. So we know that there's 450 newtons of force applied to the handle, and it's the same scenario. What we're trying to do is find what's the magnitude or the amount of force applied both vertically and horizontally. So X and Y. Okay, so based on everything we talked about a second ago, okay, Erica, how would you like me to solve for X? Oh, and I forgot the angle measure. This is 56. Just use cosine? Okay. So I'm trying to find X, so I'm going to say cosine 56 degrees. What would that equal? X over 450, 450 over X. X over 450. And again, I'm going to go ahead and put it in the double bars because we are trying to find the magnitude. So over 450. And then we just have to multiply by what? 450. Here we go. Okay, so who can help me out? How many newtons of force are we using horizontally to push the mower? I got 251.6. There we go. 251.6 newtons. Has anybody already determined the vertical magnitude, that amount of force? Aiden, what'd you get? I got 373.1. Yes. You can just solve it, the same way. 373.1 newtons. Perfect. Any problems? Anybody having issues? Okay. So I know what you're thinking, man. That was way too easy. Could we go back to one of those problems like we were just working? Okay. All right. So again, the top portion right here is just, again, the same information we've been using throughout the previous set of notes, what we've been doing on this one, that the horizontal component is the magnitude times cosine theta, the vertical is the magnitude times sine theta, and you can find the direction angle using tangent of theta equals b over a. The only thing, remember, for these formulas, okay, theta begins rotating where? From the positive x-axis, yes. Okay, we always got to start there. So here's our problem. It says a quarterback running forward at 5 meters per second throws a football with a velocity of 25 meters per second at an angle of 40 degrees with the horizontal. What's the resultant speed and direction of the pass? Okay, so I'm looking to get somebody up here to help me out because you're probably tired of listening to me work all the problems. I want to get up there and do one of these. Right? So what are the two vectors we're talking about? What items in the problem would represent the vectors we're going to work with? What's one of them? Okay. Or let's just break it down to make it even easier. What's moving in the problem? Okay, so the ball. So one vector is going to be represented by the ball. And the other one's the quarterback. There we go. Okay. So why don't we go ahead and say that the football, we'll just call that vector F, and then the quarterback, we'll go ahead and call that vector Q. So we know that the resultant should equal F plus Q. Okay. All right, so who wants to come on up and help me with this? Okay, well, I've got the random number generator up here. So let's see whose lucky day it is. Okay. 32. Okay, so I believe that is behind Jack. Okay, so try again. 14. That is Skylar. Okay. All right. Thank you, Skylar. Okay. All right, so we're going to help you out. Let me get back over here to the problem. Okay. So we need component forms for the football F and the quarterback Q. Which one of these do we not need to use the formula for? And the quarterback. Okay, because conceivably we're playing football, we should be running on level ground, right? So he's running horizontally. So what would you say Q would equal? Okay, did you hear what they're saying? Or are you okay? Just 5? That's part of it. There we go. Okay, so let's go ahead and put. Okay, so that's a component form of the football player, Q. Now for the football, we have both the magnitude, the speed at which it's moving, and the direction angle. So here, when we're talking about, from the horizontal, we're talking about his line of sight. Okay. Now we started it off correctly, but remember, how do I incorporate that angle theta into it? What do I need to multiply the magnitude by? There you go. So it'd be 25. Okay. There we go. Okay, Christian's correct. There you go, because cosine is the x value. 25 cosine 40, comma 25 sine 40. Good. Now, let's help them out real fast. What is the decimal value 25 cosine 40? 19.15. Okay, perfect. And 25 sine 40. 16.01. 07. Okay. Okay, perfect. So now we know that the resultant force would be F plus Q, or resultant magnitude. So R equals 50 plus, there we go, 19.15, 16.07. Good. Just add them up. That's right. So 24.15, 16.07. There you go. So we have the component form of the resultant. How do I use that to find the resultant speed and direction? Okay, there's that formula again. Square root of a squared plus b squared. Okay, the component form gives me a and b. Perfect. And somebody help him out with that. So what's the magnitude? What's the actual speed of the ball? Okay. 20 what? Okay, so I'd say about 29, what are we talking about, meters per second? Yeah. Okay, there you go. So about 29 meters per second. Good. And now we need to know the direction angle. So what do I do here? So from his line of sight, in fact, at what angle was it thrown? What angle of elevation?
Is that the tangent? No, B.
There you go. Christian's got it again. So tangent of theta equals B divided by A. So again, we're using the 24.15 and the 16.07. There you go. So we have to take the inverse trig function. So somebody help him out. What angle theta am I looking at? 33.6 is what I'm hearing? That's absolutely right. That's what I got. 33.6 degrees. Does anybody want to see me put that in the calculator? Either of them. You do want me to put it in the calculator? Okay. All right. Thank you, Skylar. Did a good job. Okay. So we've got tangent of theta is equal to that ratio. So tangent inverse of, what was it, 16.07 divided by 24.15? Is that what it was?
Yeah.
Okay. And there we go. There's the 33.6 degrees. Did you want to see the magnitude put in there?
No.
No? Okay. All right. How are we doing? Anybody confused by any part of these problems? Yes, ma'am. Oh, sorry. Well, from my point of view, I saw a hand and I was looking at Jane. I didn't see Connor. So, not saying that you're a woman.
Why would the direction of theta not be like
Well, you could, but we did this with his line of sight, the horizontal, so we just kept it the same. There's also one other thing that's interesting about this problem I want to go ahead and bring up. Nobody in here mentioned it, but I just want to make sure, if I were to go ahead and look at this graphically, okay, we went ahead and just believed that, the quarterback was running to the right, okay, but could we have been on the opposite side of the quarterback and seen him running left? Yeah, so if I were to work that out, a few things would change. Like that would be the quarterback, so that would be negative 50. Okay. And then he's throwing the football again, but for this one, I would have to rotate theta into the second quadrant. Is everybody okay with that? So again, it just depends on your perspective, but that should still work out just the same, no matter what side of him you're on. Okay, good. All right. Well, the other classes, just like normal, we are a little ahead of them. The other ones we had just enough time. I wanted to go ahead and just kind of talk about this one. We didn't finish the problem. I'll kind of leave that up to you. But I just wanted to go ahead and really just emphasize the idea here. It says a video camera that follows the action at a sporting event is supported by 3 wires. So we have the first, second, and third right here. The tension in each wire can be modeled by a vector. So let's pretend this is the origin right here. First one, second one, and then the third one. Okay, I just want to really emphasize the idea about using the formula and the fact that theta has to begin rotating where? Right there. Where would that be? Okay, from the horizontal, the positive x-axis. There we go. So like, if I were to come up with the component form for the first wire, I would definitely go ahead and say 1200, but cosine of what? It wouldn't be 51, right? What is 180 minus 51? 100? 20? 29. Okay. And then it would be 1200 sine 129. Okay. Now, is there anything special about the second wire? No. That one would be 1000 cosine 26, 1000 sine 26, because again, it's just rotating off that positive x-axis. But there are actually 2 different ways you could write the component form for the third wire. Okay. So let's start out. 700 cosine. Can anybody tell me which one of them? Remember, as long as you rotate from the positive x-axis, you're going to be okay. You could say negative 39. You could rotate clockwise. So you could use the same value right there. 700 sine of negative 39. And knowing that cosine is even and sine is odd, see, it's still going to put you in quadrant 4. So what's the other value I'm talking about? 141?
Yeah, because you could go all the way.
Well, if I go all the way around, though, 321. There we go. There you go. You had the right idea. We were just a little off. So 321 would be the other angle you could use. Either of those would give you exactly what you need. Okay. Is there anybody having trouble with these vector word problems? Okay. Do we like them? Not too difficult? Okay. Next time you watch a football game, oh my God, that's a vector. Probably never thought of it before, but some of you might start thinking about it now. It's kind of cool. You actually see math in action, but you don't realize it, right? It's what? Projectile motion. There you go. Okay, so unless anybody has any questions, that is all I got for today. All right, good, good, good. Don't forget, what is tomorrow? The quiz. Okay.